All right, so knowledge check 3.5.1 builds right on top of the previous knowledge check. So I've got that same code up here, and you saw that I created a logistic regression model for our attrition data, called that M1 here. And then I also created the k nearest neighbor model as M2, and it's the same model specification. Attrition is a function of age, distance from home, job level, and that's it. All right, so knowledge check 3.5.1 simply wants to take those models and make predictions on the test data. All right, so let's go ahead and do that. So this first one says make predictions on the test data using the logistic regression model. So I called my logistic regression model M1. And now what I want to do is go ahead and predict based off of, it says, the test data. So recall up here when we split our data, I saved my test data as test strat. So I can go ahead and do test strat. Run that, and I see I get my prediction. So in this case, for the first observation, my test data, I'm predicting no. Second observation, I'm predicting no, and so on. Now, a cool thing here is within predict, say you don't want the actual class, but you want the probability of that observation being of class no versus class yes. Well, we can go ahead. There is a parameter in here called type. And I could say within predict type, I want to get, instead of the class, I can get the probability. Now, when I do that, I get this probability, right? So now the way to read this is for that first observation in my test data, my model is saying that there is that the probability of that observation being no, or that employee not attriting, is 0.9, where the probability of them attriting is 0.098. Okay, and we could go down and we could see for this observation down here a little bit lower, the probability of that employee not attriting is 0.72, where the probability of them attriting is 0.28. So instead of just simply getting like the class, in this case, the binary response of what our model is predicting, if I wanted to see the probability for each of those binary classes, I definitely could do that simply by adding this type equals prob. All right, so that's for our logistic regression model. Now, number 2 said make predictions using the k nearest neighbor model, right? So recall that I called the k nearest neighbor model M2, and I can go ahead and do the same code, predict, and it is test strat. And I see the default is I get the class. Again, pretty much all these first 10 classes are being predicted as no, those employees are not going to trip. But if I wanted to see, well, what's the probability of this model predicting, I could go ahead and do type prob. And now I get the probabilities for each observation, whether or not they will attrit, which is here, yes, or they will not attrit, which is no.